Since newer JavaScript involves newer ways of working with data fetched from the servers, it is very important for you to understand how promises and async await functions they work. But before jumping into those buzzwords, what I would like to do is I would like to take this lecture to introduce you, if this is your first venture, into the world of asynchronous programming. There is an A there, asynchronous programming. And in this lecture, what I would like to do is I would like to go through like a couple of very simple examples just to show you how asynchronous programming works, what is synchronous programming, and what is asynchronous programming, which is the opposite of synchronous. Now, asynchronous programming is basically when a program starts a long task. While performing the long task, it can still do other things rather than waiting for the long-running task to finish, then do other stuff. Now, the idea behind learning asynchronous programming is that most of the tasks in a real-world context take an unknown amount of time to finish. And the other point is that we don't know how long they're going to take. So we need to understand how synchronous code works, and we need to understand how asynchronous code works. I'm going to give you a real-world example right now of why asynchronous programming is very important. Let's say you're logging in or signing into Facebook. And you know Facebook, as you're scrolling down your feed, new items, new posts, they're going to appear. And it doesn't matter how much you scroll. New items will always appear. New posts will always be fetched from the server and they're going to be shown to you. But during that process, what you can do is you can maybe set a status. You can maybe comment on a post that has already been shown. You can maybe react to a post, right? At the same time, in the background, what the application is trying to do is it's trying to grab, depending on your scroll position, all the data, all the posts that are relevant to your feed. So it doesn't matter how many posts there are. As you're scrolling, the data is being fetched from the server. Now, this is asynchronous programming. Why? Because imagine you are scrolling, and as the data is being appeared, you can't do anything else. I mean, you can't comment, you can't set a status, and you can't do anything. That would be synchronous code. So in synchronous code, the application, it has to wait until that certain task has finished. But in the case of YouTube or in the case of Facebook, it seems infinite, right? It seems infinite, like an infinite stream of data. That's why this asynchronous programming concept is so popular, it's so important, and it is actually in the core of the modern web and modern websites, that we can't wait for something to finish so we can do another thing. We want to do multiple things at the same time. Now, let me give you first an example of synchronous code, and then we are going to see what are the shortcomings of synchronous code and why we need to come up with a better way of writing our applications, better way of dealing with data that comes back from the server. What I'm going to do is I'm going to keep it very simple. Let's say we have a movie and the movie name is Scarface. And what I would like to do is I would like to say I'm going to put it right down here, let my favorite movie be equal to, I'm going to use template strings. I'm going to say my favorite movie is this movie variable that we have there. And I'm going to console log this, my favorite movie. And when I jump into the console, we can see this, and it's normal, right? It's very simple. I shouldn't even talk about it. But what is actually happening here? There are three things happen here, and I'm going to explain it to you in these steps as they're happening. This is called synchronous code. This is not asynchronous. Why? Because synchronous code happens one after the other. So what happens here is first a variable movie is declared, and then a variable my favorite movie is declared along with their values, and then their value, the value of my favorite movie, is logged on the console or to the console. Now we should note here that the browser effectively steps through the program one line at a time, in the order that we have written them. At each point, the browser waits for the line to finish its work before going to the next line. Now, the reason that it has to do this is because each line depends on the work done in the preceding line. So, if I want to use the movie variable value right here, I need to wait for this line to finish. And if I want to console log the my favorite movie, my favorite, is this misspelled? Yep, favorite. Let's remove the A. Let's save that. If I want to log the value of my favorite, this line, line 2, has to finish before I can run line 3. So every line depends, every next line depends on the previous line. This is synchronous code. And we can, I'm going to show you another example of synchronous code. Let's actually define a function. And in this function, I'm going to say movie list. And I'm going to pass in movie as a parameter. There we go. And I want this function to basically return this value. I'm going to put it right here. Cool. Let's call the movie list. And what we're going to do is we're going to actually call it, you know what, I'm not going to call it. I'm going to say let my movie is be equal to Scarface. This is not normally how you would do it, but this is important for me to be able to show you how synchronous code works step by step. And then I'm going to create another value, and I'm going to say favorite movie is equal to movie list, and for the argument, I'm going to pass in my movie, right? And I'm going to say console.log. The reason that I'm going this way is so each line depends on the previous line. Favorite movie. And when I save it, we can see my favorite movie is Scarface. It's basically the same process as before. It goes one line after the other line, one line after the other line. Now, this is called synchronous code. But the issue with this is if we have an error at any of these lines, the code is not going to run. And our entire application is going to fail. That's why when we're dealing with servers, we try to use asynchronous code. And I'm going to show you an example of asynchronous code here as well. So I'm going to say let movie be equal to, we don't have any values, right? Commented everything out. I'm going to say let movie be equal to interview with the vampire. If you haven't watched it, watch it. This is a great movie, classic. Now I'm going to say let movie be equal to interview with the vampire. And here, after that, I'm going to use a function called setTimeout. SetTimeout is going to grab a timeout, is going to grab a time, and after that time is done, it's going to do something for us. So after 2000 milliseconds or 2 seconds, what do I want this function to do? This is an arrow function, keep that in mind, because it grabs a callback function, and arrow functions are at their highest usage when it comes to callback functions. Console.log, and I'm going to say what? I don't know what to say. I'm just going to say what. So something like that. Maybe remove these. Maybe put the question sign right here. So what I would like to do is, I shouldn't have probably saved that. I need to explain it first. Console.log, and I'm going to pass in movie. And when I save it, I did say this is asynchronous, but think this is synchronous. What would happen? This line would run, then this line would run, and we would wait 2 seconds for this function to finish. And after the set timeout, is completed with this 2 seconds, it's going to print what, and then it's going to print movie. So on the console, we synchronously, we should see what first, and then we should see the value for this interview with the vampire. But we see the movie value first, and after 2 seconds, we see what. And that's why this is called asynchronous code. Now, what is actually happening here is a little bit of theory that I'm going to embark upon, and I'm going to try to explain it in the simplest terms possible. Now, JavaScript is the kind of language that is called single-threaded blocking, and the first one is actually synchronous. Now, JavaScript is not an asynchronous language. It is a synchronous language and not asynchronous. So JavaScript is synchronous, single-threaded, and it is blocking. What does that mean? We talked about the synchronicity of the language, the synchronous nature of the language in here. We know that. But what about single-threaded? Single-threaded basically means that JavaScript can do one thing at a time. So JavaScript only has one thread, and that thread's function is to do something for us based on the application that we have. So if we want to log something to the console, it is going to log it to the console. If we want to grab the user input, it's going to grab the user input. It is single-threaded, so it can do only one thing at a time. And it is blocking. And what does that mean? It means as long as the previous lines have not run, I'm not going to run the next line. That's what blocking actually means. So imagine this again, this synchronous code. If we don't run this first line, the second line is never going to run because it is blocking. So the block of this application flow, the flow of this application is blocked by this first line, and the flow of this line is blocked by the first line. The flow of the console log is blocked by the second line. And anywhere in this application, if none of these lines run, then there is going to be an error. So this is JavaScript. But this is not true when we talk about asynchronous code, because we just saw, and I'm just going to save it again, we just saw it is doing two things at a time. It is counting 2000 milliseconds, and it just printed this console log movie as well. So it clearly is doing two things, and it is not blocking, and it is not synchronous. But that is not true. JavaScript, in fact, is synchronous, single-threaded, and blocking. It blocks the flow of application. So there has to be something else that is playing a major role. And this is where the JavaScript friends come into the picture. The browser that all developers online show you the console, and they immediately jump into the console and they show, okay, here is the console, you can work with the console. The browser is actually one of JavaScript's friends. Now, the browser has specific web APIs. Now, this is a very, very broad topic. I'm not going to jump into too much detail. I'm just going to give you the gist of it. You can go to MDN and you can learn more about web APIs. There is just a ton of them. In fact, I would like to, what I'm actually trying to do is I'm trying to plan on adding these APIs to my course, to my JavaScript course on Udemy. There are some APIs, web APIs, but I want to actually expand on them a little bit more, and I'm going to update my course in the near future, and I'm going to be adding all these APIs in there. Not all of them, most of them. Now, what web APIs allow JavaScript to do is they enhance the capabilities of JavaScript. It's exactly, web APIs to JavaScript are what extensions are to VS Code. It's exactly the same thing. So extensions for VS Code, they enhance the capabilities of VS Code. Web APIs enhance the capability of JavaScript. Now, what happens here is, this is asynchronous code, but because of web APIs, this is a asynchronous code. Now, this set timeout function that you can see is written here bold and proud. This is not actually a JavaScript code. The syntax belongs to JavaScript, but this set timeout is actually a web API. This is something that has been provided to JavaScript by the browser. And it doesn't matter which browser you use, all of them have it. All modern browsers have this set timeout as a browser API. Again, just go and take a look at the list and you will see what methods, what functions, what capabilities the browsers provide JavaScript. So what happens is JavaScript is still synchronous, single-threaded, and blocking. So what happens is JavaScript runs this line, and as soon as it gets to this line, it sees, oh, this is a set timeout function. This is beyond my capabilities. So JavaScript gives this set timeout function back to the browser. So it tells the browser, okay, my friend, this is yours, it's not mine. So go ahead, please count to 2000 milliseconds. And after you're done, just give it back to me. Remind me to implement or execute this function after 2 seconds. I'm not going to think about it because I'm lazy. I'm going to do one thing at a time. It's your job. So JavaScript runs this line. It comes to this line. It gives this set timeout function to the browser, and it moves on. And it runs this line. That's why movie Interview with the Vampire, it is printed first, because before the browser being able to count to 2000 milliseconds, JavaScript is really fast. It just printed that, and after 2000 milliseconds were up, the browser reminded JavaScript, okay, you gave me this. Are you going to print it or not? And the JS engine is going to print it on the browser, and it's going to implement this function. So JavaScript is only responsible for this arrow functions that I've highlighted. The rest is the responsibility of the browser that's counting. Now, it doesn't matter if it is 2000 milliseconds or 100 milliseconds. It is still going to be, JavaScript is still going to be faster than 100 milliseconds or even 10 milliseconds. See? Even 1 millisecond, because JS engine is very fast. It's lightning fast. And even though it takes the browser 1 millisecond, 1/100th of 1 second to count it, JavaScript is faster than that. That's why the modern web is the modern web. If it wouldn't be modern web if JavaScript was slow. So even if there is like 1 millisecond, JavaScript prints this first, and then the browser is going to remind JS, okay, here is 1 millisecond is done, just go do your thing. And JavaScript doesn't even take a look at the setTime function. It is just going to run this arrow function because setTime is done by that time. And when it runs it, it first ran this line and then this line came. It would be like this. So if I cut this, get rid of it, and put it right here. Cool. So that's exactly how that asynchronous process went ahead. Cool. So now you have like this general overview of how JavaScript handles asynchronous code, asynchronous programming, because it's not alone. JavaScript has friends. There are a couple of other friends as well, but I'm not going to talk about it. If you want to learn more about this entire thing that I've told you, there is actually a video here on YouTube, the event loop explained, something like that. There is a guy, a very, very cool seminar on this event loop, and they tell you how JavaScript implements asynchronous programming under the hood. And if you want to become a fantastic JS developer, you got to watch that. It is incredible. It's got millions of views, and it's just awesome. It's a little bit old, like a few years back, but it's a gem. It's here on YouTube. It's, I think, from the channel JSConf. JSConf, I think, is the abbreviated version. Just search for it. The event loop, there's a skinny guy. I shouldn't say skinny, but I'm just telling you how to identify which video it is, because there is a lot of videos on events. That's from JSConf. You can take a look at that. It's a fantastic presentation. I loved it when I watched it. I think a couple of years ago was the first time that I watched it. It is like the best representation, the best explanation that you can find on an event loop. And it tells you all of this that I just explained. It's actually there. And there are other websites that allow you to visualize how JavaScript and browser exchange data, exchange methods, exchange properties. They actually let you visualize that. I actually forgot the website for that. I'm gonna, if I found it, I'm gonna post it in the video description, but I'm not gonna promise anything. Just go ahead and search for it. You need to be good at searching anyway, so just go ahead and find it. But do watch that seminar, that conference. It's amazing. It's the best conference you'll ever watch on JavaScript. There is actually another talk, and that is by Wes Bos, another one of my very favorite instructors, developers, and that is about async and await, which we are going to talk about. There is another talk on here on YouTube, which is a fantastic talk. You know what? I'm gonna put the links for these two talks at the bottom of this, in the description for this video. Not at the bottom, but towards the start. So you can just click on them and you can find them. And they're fantastic resources for you to really grasp what asynchronous programming is and why we need asynchronous programming. Just keep in mind whenever we want to work with servers, because it's going to take some time. We don't know how much time it's going to take, but we still want our application to run despite of, or in spite of how much time is run. We are going to use these asynchronous functions, asynchronous code, and we're going to use we are going to fetch data, the APIs, the REST API, JSON. These are incredibly important concepts. These are actually the concepts that make you into a full stack developer. These are real world stuff. So, and it's very good to learn it, to actually visualize it from the most fabulous developers in the world. So I'm gonna put the video links in the video description. You can just click on them and they're gonna redirect you to their videos, and it's amazing talks, amazing conferences. See you in the next video.